New research paper by Google DeepMind, training language models to self-correct via reinforcement learning. So this could be our way to better understand OpenAI's O1, although OpenAI's O1 I think is a bit different than this, but this is the first step in understanding it for sure. We will learn basically that current methods of teaching AIs to self-reason are insufficient. For example, prompting it doesn't yield better results, like telling it like self-improve or think step by step doesn't really like bring it to the next level of reasoning. And even the current reinforcement learning methods and research and fine-tuning methods don't do a good job, but this method is the beginning, is the first step, and shows how to get meaningful improvements by training AI with reinforcement learning to self-improve during the inference time, the test time, like OpenAI's O1 does. So everybody wants to give AI's ability to think during the inference time, during generation, and self-improve their outputs. It didn't work out so well, but then they invented this score technique that significantly improves an LLM self-correction ability using entirely self-generated data. When applied to Gemini models, they get 15.6% and 9.1% improvement on math and human eval benchmarks. Since LLMs are good in reasoning and scientific domains such as maths, they should be able to implement algorithms easily. So they should be able to implement some algorithm that will help them self-correct. However, that's not the case with current modern LLMs for some reason. Then they say that LLMs already have the underlying knowledge to do, for example, these mathematical proofs that they are talking about, but for some reason are just not able to draw upon their knowledge. And if a human helps them a little bit, then they're able to complete the, for example, mathematical proof, but they're not able to do it from scratch all by themselves. So in theory, if they have multiple tries, or if they draw knowledge from their previous responses, they can complete the solution all by themselves. Let's take a look at some graphs. So this is direct generation, the green line. So this is the base model. You see that it has test accuracy on math about 53%. And then we say self-correction. So it's gonna correct itself back to 42%. So it actually performed worse with self-correction. It decreased by 11%, just the base model. Now we have these two old methods. So this method actually increased the accuracy by self-correcting by this percentage, small percentage, and this percentage as well. And then their new method, score method, increased accuracy on math test by 4%, from around 60 to around 65. And on this right graph, they compare parallel samples and sequential self-correction. So that means, so in parallel samples, they give it a task, and then they generate a bunch of answers parallelly, and then they pick the most common one. And so as they pick the most common one, you see that performance is increasing from 60% to around 67%. And then the green line shows if they generate answer to the task, and then they let the AI correct that generated answer. It's not just generating a bunch of them parallelly, but self-correcting on the answer. Then we can see that they get up to 70% performance. So here in the 6.2 section below, they expand on this idea. So they actually use both of those techniques together. So first, they create a bunch of solutions in parallel. Then they pick the most common solution. This is called majority voting. And then they improve, sequentially improve on those solutions. And if they just do solutions parallelly, they have 7.4 accuracy gain. But while combining it with sequential sampling using self-correction yields 10.5% improvement. So if they use both of the techniques together, they get 10.5% improvement. In this section below, they say that prompting for intrinsic self-correction just doesn't work. There are some scientific studies that try to make the AI improve itself just by prompting it better, but those studies, even though they have shown some result, they have been done poorly, and so they are not so valid. And the only way to really improve to get better results with prompting is to sample multiple results and then pick the best one. And when it comes to fine-tuning for intrinsic self-correction, all the techniques that work either require humans or a better model to correct the worst model. And DeepMind wants to make the model correct itself instead. Their goal is to develop an approach for training LLMs to improve their own predictions by entirely training on self-generated data. And this is exactly what they want to do. They want to have a problem. They want to have model try to generate multiple solutions and then give all of that like problem and solutions together and auxiliary instructions, like for example, instructions to find a mistake and improve the response. And then the problem would solve the problem X as correctly as possible. Here is one example. They have this mathematical problem and turn one solution is incorrect, and then they give some self-correcting instructions. There might be a problem above because you don't even understand the question, and then the second solution is correct. So here they show standard training. There is a prompt, foundational model, and response, and that's it. But in their training, they have prompt, first attempt, and then they plug that first attempt back in, and then another like input like this self-correction instructions, like correct this this output, and then we have improved response. Although this does look like what we do every day in ChatGPT, we just like tell it like improve this response. So let's see how this is different. To understand this other part, we will just skip to see how they measure it, and then we will understand how it works as well. So first, they measure accuracy at first attempt of the solution. Then they measure the accuracy on the second attempt. So just tell the AI like improve this answer. And then they see the difference between these two accuracies. So what is the improvement from the first attempt to the second attempt? Then they also see which fraction of problems became correct when going from first attempt to second attempt. And they also saw which fraction of problems became incorrect. So they were correct in the first attempt, but then the AI was told to improve them, and then they became incorrect. So this metric that measures how many new problems become correct shows the self-correction capabilities of the AI, and this last metric that shows how many problems became incorrect after the supposed self-improvement shows how much AI is able to understand what makes a response correct. If we scroll down below, we can see the main problems that they found with previous solutions. So the star method only generated a little bit improved responses, so that was not very useful. And this pair SFT generated actually worse improvements, so it made the responses worse than previous answers because the training data was very different from the way this model would answer. So to improve on these problems, they will first train on data that the model generated itself to improve the mismatching of the data. And also they need to make sure that model doesn't fall into the trap of only generating small improvements. So then there is a lot of text that explains how this method works, but let me simplify it. What they focus on here is not improving the first answer the AI gives, but improving the second answer after the first answer. And this is the whole focus. So they try to keep the first answer not too much modified, not too much improved, the same as AI would usually give it. But then they deploy different strategies to improve the second answer, to really teach the AI how to improve. They give the AI a lot of reward if they improve the second answer. So not just get the first answer on the first try, but actually they look at the improvement and they reward the improvement from first to second. So basically the model should be able to give a good guess in the first answer and then recognize the mistakes and then make meaningful improvements in the second answer, which previous techniques fail to do. I wrote some summary notes here. So they apply KV divergence loss on the first answer, punishing the AI if it answers too differently from what it would usually answer. So this new technique doesn't change the underlying model, just teach the AI to reason. And to prevent premature convergence to a bad answer, instead this forces AI to make the first answer very similar and then use second step to revise and improve it. This strategy makes model develop a more generalizable self-correction capability rather than simply overfitting to a specific set of high-quality initial responses. In this way, stage 1 prepares the model for the second stage that promotes meaningful revisions over trivial changes. Here we have some further research topics. More sophisticated methods can teach models reasoning and self-improvement algorithms. Multi-turn reinforcement learning is probably a powerful tool for training LLMs to reason over multiple steps. The two-stage approach with reward shaping suggests that it's important to carefully design regularization techniques for LLMs to learn general techniques. Thank you for watching. Leave your comments below. Also, what helped me understand all of this is Google's Notebook LM. I'm just like mentioning it for no reason. I don't know why I'm mentioning it, but you can use this to understand the papers as well as read the papers. So yeah, see you in the next video.